In this video, we are mainly just solving and checking our answers. You can check algebraically or graphically, so I will show both options when we're doing this video. Our first strategy that we're going to use, though, is something that's going to help us with getting rid of the stuff surrounding the radical. Notice the radical is highlighted in blue. We're going to replace the radical with r. You could pick any letter, I just figured r was appropriate. So I'll make this 2r plus 3 equals 9. And then we're going to solve for r. This is not something that you have to do, but you do have to solve for the radical before squaring both sides. So this kind of helps you see that we're first subtracting 3. And then we're dividing by 2. Now at this point, you could put the radical back in. I'm showing out probably extra steps here that you won't necessarily need. So once the radical is fully solved for, we're putting the radical back in. And then here we're either squaring both sides, cubing both sides, depending on what radical it is. So square both sides for this one. Solve and check. And the checking is to make sure that we have a solution and that it works. Oops. So we get an answer of 13. Two ways to check. I can plug 13 in and make sure that it comes out to be equal to 9. Or I can plug this in the calculator. So first, I'm going to plug in 2 square root 13 minus 4 plus 3, and that does give me 9. Or I could go to the y equals, and I can plug this in. Now, I'm going to do something kind of weird. I would have to subtract the 9 from both sides. You could combine that with the 3. I'm just putting it in a slightly weird way. Now, the problem with checking 13 as a solution here is it's outside my window. So it's not always the best way to check it. I'm just going to increase my x max so I can see that crossover. And you can kind of see it happening at 13. I think it's probably easier to just check it algebraically at this point, but the graphing is an option. So I think from now on we'll just go with the algebraic option. All right, second one, very similar. We're just going to be working with a cube root instead of a square root. So it's very important that when you put it back in, you put back the index. And I'm going to do the same thing just without the color coding. So I'm going to put r in for the radical, solve for r. And then put that radical back in. Now in this example, instead of squaring both sides, we are going to cube both sides to get rid of the cube root. And even though you're showing cubing, sometimes people still multiply. They might do 3 times 3 instead of 3 to the third. So really make sure that you do this from here to here correctly. Then you might have a 1 or 2 step equation to finish solving out. Here we get x is equal to 32. And again, we'll do a quick check on the calculator. Now there's different ways you can type this in. I'm going to put in parentheses 32 minus 5 to the 1/3. To me, typing in that way as a fraction exponent is quicker, and it does come out to be 11, which is good. You could also put in 2 plus 3, go to math, and select cube root. Also not a terrible way to do it. And that comes out to 11 as well. You'll notice it actually does put a parentheses around it in the calculator for you if you have that updated version. All right, we're just going to do 2 more examples. These are a little bit different, but they do have something to do with radicals. We're just going to be working with the fraction exponents. So I'm actually going to make this into a radical equation. I'm going to make this 4th root of 2x cubed. Remember, we have different ways that we could write that. Plus 2 equals 10. Now I could put r in for this, but there's only one thing to subtract. So if there's only one thing to do, you might want to not put the r in and waste that extra step. Now this is a 4th root. I've gotten the radical by itself, so I'm going to raise both sides to the 4th. I get 2x cubed, still in parentheses. 8 to the 4th is kind of a big number, 4096. But now we have something cubed on the other side. So I'm going back and taking the cube root. We'll talk about another option to do this when we go over homework. You just want to be careful where the parentheses lie. So if you have parentheses, you would cube root first. If you don't have parentheses, you would divide first. So you want to pay attention to your order of operations when you're doing these questions. We do get x equals 8. And then a quick check. 2 times 8 to the 3/4 plus 2. We want that to come out to be 10. Oops. And it checks out, it does come out to be 10. Now the check that I'm writing here, this is really something that you can do in the calculator. You don't have to write it out, but I want to show it in the notes to show that we are doing it. And to remind you that when you're doing your own practice that you should be checking. This next one's kind of similar. You just have to keep getting rid of your different radicals. So our first step here would be to get rid of the cube root. We'll cube both sides. This is actually, I think, even a little easier than the first one. And then once we've cubed both sides, we're going to square both sides because we have a square root next. If you have 3 radicals, you would just have to do that same process 3 times. And there are other options because we can use fraction exponents, but I think this is probably the quickest way for both of these. All right, and then real quick checking one more time. We're going to put in cube root of square root of 67 minus 3. You probably could check that without the calculator, but let's just play it safe and do the calculator. And it does come out to 2, so we are all set. So you'll see some similar problems on the practice. And we will also, when we go over some of those problems, look at some different ways to do these last 2.